Okay, this section here is section 4.3, and it deals with factoring of higher degree polynomials, and we're going to be using specifically, and this is going to be cut into two parts. We're going to be looking specifically, first of all, at the remainder and the factor theorem part of this section. Now, if you're looking in your textbooks, the remainder theorem is on page 122, and the part one of the factor theorem is on page 123. And I'm just going to start by using the remainder theorem here. And what the remainder theorem says, that if you have a certain polynomial and you divide it by a binomial in a special form of x minus something, they use always a minus here, then you can obtain the remainder by subbing in the value of whatever this number is here into where x would be into the polynomial, and that would give you the remainder of the question. So let's do that example first. So remember that always you're going to use the opposite sign of the number that's with this binomial when you're doing this remainder theorem idea. So what we will do then is we'll simply plug in x is equal to -2. Okay, and the way I remember that is just remember that if you go x plus 1 is equal to 0, or sorry, x plus 2 is equal to 0, then x would actually equal -2. So that's the way to remember that if you were solving for x. Okay, so if I work this through then, oops, I was going to put x there. 4 times -2 cubed minus 2 times -2 squared minus 7 times -2 plus 5. So if we work that out, 4 times -2 times -2 is 4 times -2 is -8. And -2 times 4 plus 14 plus 5. So we have -32 minus 8 plus 19. So -21 is our remainder. Therefore, our remainder would be given here as a -21. Okay, and that's the first type of question that you can get in this section, using the remainder theorem. And there's another one, there's the factor theorem, and there's two types of questions that you can get using the factor theorem, and specifically there's a couple parts to it, but we're going to look at the first part. Basically, what the factor theorem says is that if you take a polynomial and evaluate it, and you want to find out whether or not this is a factor of that polynomial, you just simply plug in that number, and if it works out to 0, meaning it has no remainder, then you would get, yes, then indeed it is a factor. So let's look at an example of that. So my example for that, I'm going to move this up and check the field of view here. My example for that is this. Is x minus 3 a factor of the polynomial 2x cubed plus 5x squared minus 19x minus 42. So according to that second part of the theorem, if we take the polynomial, let's say p at, of course, if we make x minus 3 equal to 0, that would be 3. If that is equal to 0, then yes, we have a factor. And we don't know yet, but will be a factor, we'll say. So we just simply take the polynomial and plug in 3. So 2 times 3 cubed plus 5 times 3 squared minus 19 times 3 minus 42 is equal to 0. See if it works out. So 2 times 3 times 3 times 3 is actually 27, plus 5 times 9, and 19 multiplied, or negative 19 multiplied by 3, that would give us negative 57 minus 42. Okay, if we work this out, 27 times 2, that's 54 plus 45 minus 57 minus 42 is equal to 0. Okay, so let's add these two together. We get 99. And here, if we add these two negatives together, minus and another minus, that would be minus 99. So yes, indeed, yes it is. So that one worked out. If it would have gave us not equaling to 0 there, then it wouldn't be a factor. Okay, one more example to do. I'm just going to flip my page here. And that is, using the same factor theorem, sometimes they ask you to find a certain variable given a situation. So find k such that, let's say x plus 2 is a factor. Of, and our polynomial in this case is 2x, oh, sorry, yeah, it's 2x to the 4th. I just couldn't see it there for a sec. Minus x cubed, minus 9x squared, plus 10x, plus 16. I forgot the k value, didn't I? Oops, I was supposed to put this as a k. We know what it's going to be, but that was supposed to be a k. It just looked like a 9 to me. So if that's my k value, what we would then do is we would plug in x is equal to minus 2 where x is. So that would be minus 2 to the 4th. Minus 2 cubed minus k times minus 2 squared plus 10 times minus 2 plus 16 is equal to 0. So we're using the same theorem. There's our k value. Okay, so let's work this out. 2 times 2, or negative 2 times negative 2 times negative 2 times negative 2 is 16. Or sorry, 16. And minus a negative 8 minus k times 4 minus 20 plus 16 is equal to 0. So if we were to work this out, this would be 32 plus 8 minus 4k, let's put the 4 in front, and this would be minus 4 equal to 0. Okay, if we work that out, then we get 40 minus 4 equals 4k if I move the 4k over. So 36 equals 4k divided by 4, and we get our 9 that I accidentally put in there. And that's how you do those types of questions. Okay, in our next section, we're going to specifically look at the same section, but we're going to look at synthetic division in the section.